So today our topic is instrumentation. A spectrophotometer is an instrument to measure the amount of light absorbed by a sample. Spectrophotometer techniques are mostly used to measure the concentration of solutes by measuring the amount of the light that is absorbed by the solution in a cuvette placed in the spectrophotometer. The spectrophotometer technique is to measure light intensity as a function of wavelength. It does this by diffracting the light beam into a spectrum of wavelengths, detecting the intensities with a charge coupled device, and displaying the results as a graph on the detector and then on the display device. In the spectrophotometer, a prism or grating is used to split the incident beam into different wavelengths. By suitable mechanisms, waves of specific wavelengths can be manipulated to fall on the test solution. The range of the wavelengths of the incident light can be as low as 1 to 2 nanometers. The spectrophotometer is useful for measuring the absorption spectrum of a compound, that is, the absorption of light by a solution at each wavelength. It is a single beam spectrophotometer. So the essential components of spectrophotometer instrumentation include: the first one is energy source. Materials that can be excited to high energy states by a high voltage electric discharge or by electrical heating serve as excellent radiant energy sources. Monochromator, to break the polychromatic radiation into component wavelength or bands of wavelengths. A monochromator resolves polychromatic radiation into its individual wavelengths and isolates these wavelengths into very narrow bands. Here, monochromators, prisms and gratings, two types of materials used as a monochromators. Prisms or gratings used as a monochromators. Prisms. A prism disperses polychromatic light from the source into its constituent wavelengths by virtue of its ability to reflect different wavelengths to a different extent. Two types of prisms are usually employed in commercial instruments, so namely 600 Kern quartz prism and 300 litro prism. Gratings. Gratings are often used in the monochromators of spectrophotometers operating ultraviolet and infrared regions. So, colored glasses used as a filters. So, if filters used as a slit, that instrument is called as spectrophotometer. If monochromators used as a slit, that instrument is called as simply photometers. So, but now we discuss about spectrophotometers. That means filters are used as a slit. So that instruments are called as spectrophotometers. So transport vessels to hold the samples to be studied in the ultraviolet or visible region are usually glasses or solutions and are put in cells known as cuvettes. Cuvettes nothing but small size of test tubes. So in these test tubes we are taking samples, so that glass tubes are called as cuvettes. These cuvettes are prepared with quartz. So cuvettes means for the visible region are made up of either ordinary glass or sometimes quartz. So detectors. So photovoltaic cells are phototubes used as a detectors. So most detectors, depending on the photoelectric effect, the current is then proportional to the light intensity and therefore a measure of it. So radiation detectors generate electronic signals which are proportional to the transmitter light. These signals need to be translated into a form that is easy to interrupt. This is accomplished by using amplifiers, ammeters, potentiometers and potentiometric recorders. So these materials are used in instrument, energy source, monochromators. So monochromators break the polychromatic radiation into component wavelength or bands of wavelengths. Here monochromators are filters used as a slit. So prisms are gratings used as a monochromators. If colored filters are used as a slit, that apparatur is called as, if filters are used as a slit, that instrument is called as spectrophotometers. If monochromators are used in machine, in apparatus, that instrument is called as simply photometers. So it is a single beam spectrophotometer. The first one is light source and second one is monochromator sample cuvette, and this is the indicator, signal indicator. So single beam UV visible spectrophotometer, that means filters are used as a slit, that means monochromators. That machine, that apparatus is called as single beam UV visible spectrophotometers. In single beam spectrophotometers, a single beam of light passes through the sample holder. The instrument is standardized by placing a reference in the sample holder, and the resulting value is subtracted from subsequent sample measurements to remove effects from the solvent and the cell. UV visible spectroscopy is suitable for application in the wavelength range 190 to 1100 nanometers. The UV region is considered to be any wavelength less than 340 nanometers. Nucleic acid, purified proteins and other organic molecules are often measured in the UV region. The visible region of the electromagnetic spectrum is 340 to 750 nanometers, which is used to measure samples that are colored. An appropriate spectrophotometer depends on sample type and application. Look for a sample volume range that fits your needs. The ability to change samples quickly and easy to read display, and a unit that is easy to clean and maintain. So spectrophotometers come in both single beam and double beam configurations. A single beam spectrophotometer uses a reference standard to standardize or blank the instrument before taking measurements. A double beam spectrophotometer splits the beam of light into two different paths, one of which passes through the sample while the other passes through a reference standard. Double beam spectrophotometers measure the ratio of light intensities and therefore are not as sensitive to fluctuations in the light source or detector. However, single beam spectrophotometers are usually more compact and have a higher dynamic range. It is a double beam spectrophotometer. Simultaneously, the light passing through the sample cell and reference cell. So, it is a double beam spectrophotometer. So, at a time, the light passes through the sample cell and reference cell. It is a instrumentation of double beam spectrophotometer. The light in double beam spectrophotometer, the light source, you need a light source which gives the entire visible spectrum plus the near ultraviolet, so that you are covering the range from about 200 nanometers to about 800 nanometers. You can't get this range of wavelengths from a single lamp, and so a combination of two is used. One is a deuterium lamp for the UV part of the spectrum and a tungsten lamp for the visible part. The combined output of these two bulbs is focused on to a diffraction grating. You are probably familiar with the way that a prism splits light into its component colors. A diffraction grating does the same job but more efficiently. The blue arrows, from diffraction grating, the blue arrows show the way the various wavelengths of the light are sent off in different directions. The slit only allows light of a very narrow range of wavelengths through into the rest of the spectrometer. By gradually rotating the diffraction grating, you can allow light from the whole spectrum through into the rest of the instrument. This is the clever bit. Each disc is made up of a number of different segments. Those in the machine we are describing have 3 different sections. Other designs may have a different numbers. So, if you pass white light through a colored substance, some of the light gets absorbed. A solution containing hydrated copper ions, for example, looks pale blue because the solution absorbs light from the red end of the spectrum. The remaining wavelengths in the light combine in the eye and brain to give the appearance of pale blue. Some colorless substances also absorb light, but in the ultraviolet region, since we can't see UV light, we don't notice this absorption. Different substances absorb different wavelengths of light, and this can be used to help to identify the substance. The presence of particular metal ions, for example, are of particular functional groups in organic compounds. The amount of absorption is also dependent on the concentration of the substance if it is in solution. Measurement of the amount of absorption can be used to find the concentration of very dilute solutions. An absorption spectrophotometer measures the way that the light absorbed by a compound varies across the UV and UV visible spectrophotometer. The detector converts the incoming light into a current. The higher the current, the greater the intensity of the light. For each wavelength of light passing through the spectrometer, the intensity of the light passing through the reference cell is measured. This is usually referred to as I0, that is I for intensity. The intensity of the light passing through the sample cell is also measured for that wavelength given the symbol I. If I is less than I0, then obviously the sample has absorbed some of the light. A sample bit of math is then done in the computer to convert this into something called the absorbance of the sample given the symbol A. For reasons which will become clearer when we do bit of theory on another page, the relationship between A and the two intensities is given by A is equal to an absorbance of 1 happens when 90% of the light at that wavelength has been absorbed, which means that the intensity is 10% of what it would otherwise be. In the case I0 by I is 100 by 10 is, and log 10 of 10 is 1. The absorption spectrum is a plot of absorbance against wavelength. The output might look like this. This particular substance has what are known as absorbance peaks at 255 to 395 nanometers. How these arise and how they are interpreted are discussed on another page. So the applications of spectrophotometers: detection of concentration of substances, detection of impurities, structural elucidation of organic compounds, monitoring dissolved oxygen content in freshwater and marine ecosystems, characterization of proteins, detection of functional groups, respiratory gas analysis in hospitals, molecular weight determination of compounds. The visible and UV spectrophotometer may be used to identify classes of compounds in both the pure state and in biological preparations. So instruments are two types: double beam spectrophotometers and single beam spectrophotometers. It is a single beam photometer diagram. So in a single beam spectrophotometer, the light completely passes through the sample solution. In double beam spectrophotometer, at a time the light passes through the sample cell and reference cell. Okay, that's why this instrument is called as double beam spectrophotometer. Here spectrophotometer means filters are used as a slits, so that apparatus is called as spectrophotometers. So in spectrophotometers, common factors are energy source, monochromators. So monochromator means to break the polychromatic radiation into component wavelength or bands of wavelengths. So generally prisms or gratings are used as a monochromators. That means two types of monochromators are there: prisms or gratings. Okay, if monochromators are used as a slit, that instrument is called as photometer. If filters are used as a slit, that instrumentation is called as spectrophotometers. These slit commonly break the polychromatic radiation into component wavelength or bands of wavelengths. Okay, and samples we are taking in cuvettes. These cuvettes are prepared with quartz. Photovoltaic cells or phototubes are used as a detectors. These detectors are analyzes the energy absorption light by the molecules. And microcomputers, digital meters are used as a signal indicators in these instrumentations. Okay, this is about instrumentation.